In this lesson, we are going to discuss differential equations. So this is going to be the first lesson on differential equations. So we are going to be taking a look at separable first order differential equations. Differential equations, these are equations that connect one or more functions with their derivative. Let's take a look at some examples. We want to find the differential equations. That is, we want to evaluate the differential equation, which is s squared plus 4, then multiplied by y prime is equal to 2sy. Next step you want to take is you want to write this in a form you can easily understand. So the way I like to do this is I always write the y prime as dy over ds. So I'm going to write this as s squared plus 4, then multiply by dy over ds. This is equal to 2sy. So this is basically dy over ds of s squared plus 4 is equal to 2sy. As the next step you want to take is you want to write dy on the left side and you want to write ds on the right side. So how can we do this? We are going to cross multiply. So I'm going to cross multiply. So this is going to give us s squared plus 4 dy is equal to 2sy ds. Now the next step you are going to take is, guys, let me write this with parentheses so that we can easily visualize this. So now the next step you are going to take is we are going to separate the variables. So on one side we only want to have y variables, and on the other side we only want to have s variables. Okay, so we're going to separate the y variables and the s variables. How can we do this? What we need to do, we need to divide both sides by s squared plus 4y. Okay, so we need to divide both sides by s squared plus 4y so that we can separate the y and the s variables. So we're going to say divide both sides by s squared plus 4, then multiply by y. So if we do this, this is going to be on the left side, we're going to have s squared plus 4 dy divided by s squared plus 4y. Okay, then is equal to, on the right side, we're going to have 2sy ds, then divided by s squared plus 4, then multiply by y. As you can see, guys, s squared plus 4 is going to cancel out. Okay, so on the left side we are going to be left with dy over y. So this is equal to, now on the right side we are going to have 2s over s squared plus 4. As you can see, guys, the y are going to cancel out. Okay, so this is why we have 2s divided by s squared plus 4. The next step you are going to take is you are not going to integrate both sides. Okay, so you are going to take the integral on both sides. Okay, so this is going to be the integral on the left side, also the integral on the right side. So what is the integral of 1 over y? Guys, the integral of 1 over y, this is basically ln of the absolute value of y. Okay, because this is 1 over y dy. So the integral of 1 over y is going to give us ln of the absolute value of y. So this is equal to, now we're also going to take the integral on the right side. So we are going to use u substitution to evaluate this integral. Okay, so we're going to say let u is equal to s squared plus 4. Okay, so we're going to say let u equal to s squared plus 4. So now we're going to take the derivative of u with respect to s. So this is going to be du is equal to, derivative of s squared plus 4 is going to give us 2s. Then we have to include s. Okay, so now we're going to solve for ds. So ds is equal to du over 2s. Okay, so now we are going to plug this inside the integral. So we know that this is the integral of 2s over the value of s squared plus 4, this is basically equal to u, right? So this is 2s over u, then multiply by, so this is 2s over u, then multiply by, now guys, I forgot to include the s, so this is the s, we also have the s here, okay? So this is 2s over u, then multiply by the s. Now what is the s, guys? As you can see, the s, this is the u over 2s, okay? So I'm going to replace that with the s. So this is the u over 2s. As you can see, the 2s, they are going to cancel out, so we now have the integral of 1 over u du. So what is the integral of 1 over u? This is basically ln of the absolute value of u, okay? So this is ln of the absolute value of u. So guys, we need to replace u. What is u? We know that u is equals to s squared plus 4, okay? So this is going to be ln of the absolute value of s squared plus 4, okay? So this is the value on the right side. So we now have to write this. So this is going to be ln of the absolute value of y. So this is the value on the left side is equal to ln of the absolute value of s squared plus 4. So this is the value on the right side. So guys, we need to introduce the constant c, okay? So we're going to introduce the constant c on the right side. So we're going to say plus c, okay? Now, what I'm going to do is, we want to find the value of y, right? We want to find the value of y, okay? So this is what we want to do. So we can represent the constant c as ln of c, okay? So we can represent this as ln of c, because as you can see, we're having ln on the left, we're having ln on the right, so we have to represent constant c with ln of c, because ln of c is also c, okay? So we just need to represent c with ln of c, so that we can have ln on both sides, okay? So this is going to be ln of the absolute value of y is equal to ln of the absolute value of s squared plus 4, then plus ln of c, because this is also a constant. Ln of c is a constant, c is also a constant, so we can also represent this with ln of c, okay? So now guys, what we are going to do is, we are now going to say this is ln of the absolute value of y is equal to, so we are going to say ln of, that is ln of c, then multiply by s squared plus 4, okay? Because as you can see, we are having ln, we are having the addition of two functions, so meaning we can multiply this function, okay? So it's going to be ln of c multiply s squared plus 4, okay? So now this is going to be, as you can see guys, we are having ln on both sides, right? We are having ln on both sides. As you can see, we are having ln on the left, we are also having ln on the right. So meaning we can basically cancel out the ln, okay? So this is now going to be the absolute value of y is equal to c multiply s squared plus 4, okay? So this is c multiply s squared plus 4. So guys, we know that we are going to calculate for y, right? So this is what we want to find. So how can we do this? As you can see, we are having the absolute value of y. So meaning this can either be positive or negative, okay? So what we're going to do now is, this is going to be y is now equal to plus or minus c multiply s squared plus 4, okay? So this is now going to be the answer. So this is going to be the differential equation, okay? So this is going to be the solution to the differential equation. So it is y equal to plus or minus c multiply s squared plus 4. So guys, this c is the constant, okay? So let's take a look at another example. So let's take a look at another example, guys. So let me scroll down. So this is example 2. Now guys, let's say we want to find, let's say this time around we want to find a particular solution of the equation 1 plus e raised to the power of s, then multiply by y prime, or the derivative of 1 plus e raised to the power of s, then this is equal to e raised to the power of s. So guys, we want to find a particular solution of the equation satisfying the initial condition of y of 0 equal to 0. So guys, what we want to do is we want to find a particular solution. So guys, this is going to be a bit different from the first question. Don't worry, you are going to see how I'm going to solve this. Okay, so what we're going to do is, like I said, we are going to try to write this y prime as dy over ds. Okay, so this is now going to be 1 plus e raised to the power of s of dy over ds. Okay, so this is equal to e raised to the power of s. So guys, we are going to take similar step. We are going to take the similar step. So what we're going to do is we are going to cross multiply, okay, so that we can have dy on the left, then we can have ds on the right. Okay, so this is going to be 1 plus e raised to the power of s dy is equal to e raised to the power of s ds. Okay, so now guys, like I said, we are going to try to separate the variable. Okay, so we are going to try to have y variables on one side, then we are going to try to have s variables on the other side. Okay, so how can we do this? So what we're going to do is we are going to divide both sides by 1 plus e raised to the power of s. Okay, so I'm going to say divide both sides by 1 plus e raised to the power of s. Okay, so this is going to be 1 plus e raised to the power of s dy divided by 1 plus e raised to the power of s. So this is on the left side. Then this is equal to e raised to the power of s ds. E raised to the power of s ds over 1 plus e raised to the power of s. So this is on the right side. As you can see, guys, 1 plus e raised to the power of s. This is going to cancel out. So on the left side, we have dy is equal to, now on the right side, we have e raised to the power of s divided by 1 plus e raised to the power of s ds. Okay? Now, the next step is we're now going to take the integral on both sides. Okay? As you can see, we now have y variables on the left and we have s variables on the right. So the next step is we are going to take the integral on both sides. Okay, so this is going to be the next step. So let me scroll downward. Okay, so we are now going to take the integral on both sides. So this is the integral of dy on the left side. Also on the right side, we have the integral of e raised to the power of s divided 1 plus e raised to the power of s ds. So guys, what is the integral of dy? This is basically the integral of 1, right? Because we are having an invisible 1, so this is basically the integral of 1 with respect to y. So integral of 1 with respect to y is going to give us y. So this is y is equal to. So we need to take the integral on the right side. So how can we do this? We are going to use u substitution. So we are going to say let u equal to 1 plus e raised to the power of s. Okay? So we are going to say let u equal to 1 plus e raised to the power of s. So we're going to take the derivative of u with respect to s. So this is going to be equal to derivative of e raised to the power of s is also e raised to the power of s. Okay, derivative of 1 is 0. Okay, so this is e raised to the power of s ds. So we have to solve for ds. So ds is now equal to du over e raised to the power of s. So we're going to plug these values. We're going to plug these values inside the integral. Okay, so this is now going to be this is equal to the integral of e raised to the power of s divided by, now guys, 1 plus e raised to the power of s. This is basically u, right? So this is going to be e raised to the power of s over u, then multiply by what is the s? The s, this is basically du over e raised to the power of s. Okay, so this is multiplied by du over e raised to the power of s. As you can see, e raised to the power of s is going to cancel out. So we now have the integral of 1 over u du. So what is the integral of 1 over u? This is basically equal to ln of u. Okay, so what is u? U is 1 plus e raised to the power of s. Okay, so this is ln of 1 plus e raised to the power of s. Okay, so now guys, we are now going to write this as, on the left side we have y, so this is y is equal, so this is y is equal to, on the right side we have ln of 1 plus e raised to the power of s. So guys, don't forget to include your constant c. Okay, so we're also going to introduce the constant c on the right side. So this is plus c. Okay, so now guys, because we were asked to find a particular solution of the general equation satisfying the initial condition y of 0 equal to 0, as you can see here guys, y of 0 is equal to 0. So what we are going to do now guys is, we are now going to plug the value of 0. Okay, so we are going to plug 0 wherever we see y and wherever we see s. Okay, so that we can find the constant c, because we want to find the constant c. Okay, so this is what we want to find. So how can we do this? Because we know that y of 0 is equal to 0, so we're going to plug 0 wherever we see 0 and wherever we see s. Okay, so that we can find the constant c. So this is now going to be 0 is equal to ln of 1 plus e raised to the power of 0, then plus c. So this is equal to, this is 0 is equal to ln of 1 plus e raised to the power of 0. E raised to the power of 0 is 1, right? Because anything raised to the power of 0 is always 1. Then 1 plus 1 is going to give us 2, right? So this is ln of 2, then plus c. So guys, because we want to find c, so meaning we are going to take ln of 2, we are going to move this to the left side. So this is now equal to c. This is c is equal to, so because we move ln of 2 to the left side, this is now going to be negative ln of 2. Okay, so c is equal to negative ln of 2. But guys, we are not done. We now need to replace c with ln, with negative ln of 2. Okay, so this is now going to be, so this is going to be y is equal to ln of 1 plus e raised to the power of s, okay, then minus ln of 2. Okay, so we basically replace c with negative ln of 2. Okay guys, so this is going to be the answer. You can leave your answer like this, but if you want to simplify this further, you can say y is equal to ln of 1 plus e raised to the power of s divided by 2. Okay, so this is going to be the answer, because we are having the subtraction of two functions, right? And we know that each functions contain ln, so we can basically take one ln, then we are going to divide the two functions, because we're having subtractions of functions. So this is how we got ln of 1 plus e raised to the power of s divided by 2. Okay, so you can also write your answer like this, or you can write your answer like this. Okay, so anyone is acceptable, guys. Okay, so this is going to be the particular solution of the equation satisfying the initial condition y of 0 equal to 0. Okay, so this is how we can solve differential equations. Okay guys, so this is how we can solve differential equations. So this is first order separable differential equations. Okay guys, so this is where we are going to call it. Now if you are watching my videos for the first time, try to subscribe to my channel. If you like my video, share these videos with your friend and click the bell notification icon below so that you can get notification whenever InnoTutorial upload a new video. Okay guys, see you all. Bye.